Hi, here in this given problem, this problem that is based upon the resultant of three vectors is 0. The three vectors which are acting at a point. This is the common point which is given as A. This is point A. At this point there are three forces. Tension in the chord AC, that is T, that is T1. Let it be T1. Tension in this another chord which is attached with the help of a spring AB. Suppose it is T2 and the weight of this lamp, if its mass is M, then weight mg acting vertically down. This angle 30 degrees, so here this angle that will be 180 minus 30 degree, angle between T1 and T2, angle between mg and T1 that will be total, it will become 90 degree plus 30 degree, and this is of course that is 90 degree only. Now the three forces T1, T2 and mg, these are in equilibrium. So as T1, T2 and mg are, these are in equilibrium. Equilibrium means their sum, their vector sum is 0. So using, first of all we have to find this T2. So to find that, using Lami's theorem, which says the ratio of the tension T1 and the sine of angle between other two forces, which is T2 and mg, so that is 90 degree only, is equal to T2 divided by force, T2 divided by sine of angle between other two forces, and that is 90 plus 30 degree, and finally mg divided by sine of angle between other two forces, and that is 180 minus 30 degree. Okay, so leaving this T1 by sine 90, as we need not to find it, or using these two terms only, they may be written as T2 divided by sine 90 plus 30 will be equal to cos 30, means cos theta, is equal to mg divided by sine 180 minus 30 means sine 30. So tension T2 that will be given by mg multiplied by cos 30 degree divided by sine 30 degree, plugging in all the known values here. Mass of the lamp that is given as 8 kg multiplied by g, which is 9.8, and then cos 30 by sine 30, this is cot 30 degree. So this tension T2 calculated to be equal to 135.8 Newton. So now using the value of this T2, because due to this tension T2 in the spring, there will be a restoring force also developed in this spring F, and that F, which is equal to tension T2, that will also be given as in magnitude, that will be K multiplied by delta L. Delta L is the change in its length. So delta L will be given by T2 divided by K, means 135.8 Newton divided by 300 Newton per meter. That is already given to us, spring factor. So it is calculated to be equal to 0.45 meter. Okay. Now this change in the length of the spring, that is 0.45 meter, and this total length here, that is 2 meter, and undeformed length of the spring, that is 0.4 meter. So the undeformed length that is known to us as 0.4 meter, change in the length 0.45 meter, therefore L dash deformed length, that will be 0.4 plus 0.45 meter, means 0.85 meter this is. Okay, So here this remaining length, as this total is 2 meter, so the remaining length, let it be represented as x. So this x will be given by 2 minus 0.85 meter, means that is 1.15 meter. Finally, in this right angle triangle, this angle is 30 degree. So we can say base upon hypotenuse, base that is x upon hypotenuse, that is AC, is equal to cos 30 degree. So AC will be given by x divided by cos 30 degree, means that is 1.15 divided by root 3 by 2, and finally this length, and this we have to find the required length of chord AC. So that length of chord AC, that is calculated to be equal to 1.3 meter, which is the answer for this given problem here, and that is the option D, which is correct over here. Thank you.